Now let's look at another tenet of Python philosophy and culture, the idea that it's easier to ask forgiveness than permission. There are only two approaches to dealing with a program operation that might fail. The first approach is to check that all the preconditions for a failure-prone operation are met in advance of attempting the operation. The second approach is to blindly hope for the best, but be prepared to deal with the consequences if it doesn't work out. In Python culture, these two philosophies are known as look before you leap, LBYL, and it's easier to ask forgiveness than permission, EAFP, which incidentally was coined by Rear Admiral Grace Hopper, inventor of the compiler. Python is strongly in favor of EAFP because it puts primary logic for the happy path in its most readable form, with deviations from the normal flow handled separately rather than interspersed with the main flow. Let's consider an example, processing a file. The details of the processing aren't relevant. All we need to know is that the processFile function will open a file and read some data from it. First, the LBYL version. Before attempting to call processFile, we check that the file exists, and if it doesn't, we avoid making the call and print a helpful message instead. There are several problems with this approach, some obvious and some insidious. One obvious problem is that we only perform an existence check. What if the file exists but contains garbage? What if the path refers to a directory instead of a file? According to LBYL, we should add preemptive tests for these too. A more subtle problem is that there is a race condition here. It's possible for the file to be deleted, for example by another process, between the existence check and the processFile call, a classic atomicity issue. There's really no good way to deal with this. Handling of errors from processFile will be needed in any case. Now consider the alternative, using the more Pythonic EAFP approach. Here we simply attempt the operation without checks in advance, but we have an exception handler in place to deal with any problems. We don't even need to know in a lot of detail exactly what might go wrong. Here we catch OS error, which covers all manner of conditions such as file not found and using directories where files are expected. EAFP is standard in Python, and that philosophy is enabled by exceptions. Without exceptions, that is, using error codes instead, you are forced to include error handling directly in the main flow of the logic. Since exceptions interrupt the main flow, they allow you to handle exceptional cases non-locally. Exceptions coupled with EAFP are also superior because, unlike error codes, exceptions cannot be easily ignored. By default, exceptions have a big effect, whereas error codes are silent by default. So the exception EAFP-based style makes it very difficult for problems to be silently ignored.